In the last lectures, we learned how to compile our publisher. So now let's create a subscriber node to process the data sent by our publisher. In this case, we'll just make a simple subscriber which prints the data sent over by the publisher. So with VS Code open, let's go ahead and create a new file in our source folder called subscriber.cpp. Just like our publisher node, we will need to import our ROS client library and string message types. So we can just copy these statements from our publisher script. And again, sometimes the linter will not process this correctly. I'll just go ahead and hit save, and usually that updates the linter and it finds the dependencies. We can also copy the main function, as just like our publisher node, we'll need to initialize ROS client library, then spin an instance of our subscriber, and then shut down our ROS DDS communications once we are done. From here, we're just going to change our publisher class to instead be a subscriber. Now I can define this new class above, which will look very similar to our previous class in the sense that we will be inheriting attributes from the ROS node object, and when we create our constructor, we will have to initialize a node name, which I will just call Hello World sub node. We can now create our subscriber instance, which I will do in a private access specifier. But before I do, let's check out the ROS client library C++ documentation page to see what we have to work with. So here we see the subscription section, and we see a create subscription function and a subscription object. So one thing to notice if you have worked with ROS1 is that it is now called a subscription instead of a subscriber. So you may often hear me refer to it as such just because I'm used to calling it that from the previous ROS version. But that aside, let's open these two links in new tabs. So checking out the subscription object, here the subscription generic declaration shows we need to declare a callback message type, an allocator type, and a message memory strategy type. The message memory strategy has to do with a strategy for messages received by the subscription. But for now, don't worry about it since a default instance will be created when we call the create subscription function. And the callback message will look the same as our normal message we used when declaring our publisher. So let's go ahead and create a subscription variable in our code. So I'll grab the subscription object from RCL CPP and cast the standard messages message string type. And don't worry if you are confused by this string message declaration, we will talk about it in greater detail in the upcoming lectures. The main thing is that your message type here matches the message type of your publisher. So here we're using string, which is the same as the message type we are using for our publisher. Then I will get the shared pointer of this object, and we will call it subscription with a trailing underscore. Alright, now let's head back to the documentation and check out the declare subscription method to a node class. This takes in the topic name and quality of service arguments similar to that of our publisher, followed by a callback function which will run every time we receive a new message from publishers on this topic. You can also configure your subscription options, allocator, and message memory strategy here, but we can just leave them as their default values. So let's try this out in our code. So I will reference our subscription variable and set it equal to this and use an arrow operator to call the create subscription function. Just like our create publisher function, we need to specify the message type. Now for our parameters, we got our topic name, which will be the same as our publisher. So if we head over to our publisher, we see we set our topic name to be Hello World. So this needs to match exactly, if not, it will not receive messages. And I will just give a QoS of 10, which specifies a history depth of up to 10 in case this subscriber falls behind on message processing. Now we need to give the callback function, which will get called every time a new message is received. So we will do something similar to what we did in our publisher node for our wall timer, in which we will bind a method from our class. So I will call bind, specify our Hello World subnode class, and then call a method which I will just call subCallback. Now this method doesn't yet exist, but it will be in charge of taking in the message received from the publisher. We will pass in these node attributes, and this function also has to take in an argument, which will be the actual string message we receive. So I will just use a placeholder. Cool, let's go ahead and define this function below in our private access section of our class. Now, as I said earlier, this function takes in the string message, so I can specify a message variable for this function like so. Then I'll be sure to tag on a const at the end of the function call so we can properly work with the const objects. For now, I will just have this callback function take the information and print it out to the screen. This would be a good place to use ROS loggers, but to keep things straightforward, I will just import the IOStream library and use cout to print to the terminal. In this case, I will take the message, which is an object, and grab the data attribute of it, which is what actually holds our string information. Okay, great. With that, we have created a node which creates a subscriber that listens to any messages coming in on the hello world topic. And every time it receives a message, it will run this sub callback method, which prints the message data to the terminal using cout. Down in our main function, we initialize our ROS DDS communications, spin our node, which allows this node to keep running and processing requests coming in over ROS, and then once we are done, we shut down our DDS communications. So let's save this file, and let's compile it to see what happens. As a mini challenge, try using what you learned in the previous lectures to configure our package to compile this new subscriber C++ file. How'd it go? I hope you gave it a try to give yourself some extra practice on compiling your packages, but let's go ahead and go through this together. Okay, so I'll go into my cmakelist.txt file, and I'll have to create a new set of executable instructions to compile this subscriber node. So I will copy the publisher lines and modify to instead point to the subscriber file since they have the same dependencies. I can just use Alt plus click with my left mouse button to create multiple cursors and edit all of them at once from publisher to subscriber. Then I will add subscriber to our installation targets below. Cool, with that I can save this file, and we don't have to edit anything in our package.xml file because we didn't add any new dependencies. So now we can go ahead and compile our workspace. So you could go ahead and open up a terminal, change it to the workspace directory, and here you could run colkin build, or you can use what we learned from the last lecture and simply go to terminal, run build task, or use the Ctrl-Shift-B keyboard shortcut. All right, with that done, I can go ahead and hit my spacebar to close that terminal. And now I can be sure to source my workspace. And now if I type in ROS2 run Udemy ROS2 package, I can hit tab twice and it will reveal both our publisher and our subscriber executables. So I can go ahead and run the subscriber. Okay, nothing happens. That's because we are not running our publisher. So no messages are coming over the hello world topic. So I can open up a second terminal tab below, source the workspace as before, and run the publisher. And here we see our subscriber in the upper terminal begins outputting the message contents to the terminal. And if I go ahead and stop the subscriber and restart it back up, it will start back at the current hello world message the publisher is currently at. And vice versa, we can stop the publisher, and we see the subscriber stops printing new messages unless we restart the publisher. And we see we start back at 0. So with that, I can go ahead and stop both nodes. Again, you can stop nodes with Control-C. Great. With that, you have successfully created your own subscriber nodes, which can process the message data coming in over our publishers that we created. In the next lecture, we'll talk about interfaces, which should help shed some light on what that string standard message type is, which we've been using in our C++ code. But for now, let's review what we learned. All right, in this lecture, we took a look at creating subscribers. And so in order to create a subscriber, we created a subscription object using the createSubscription method of our node class. In order to create our subscriber, we had to specify the message type, the topic name, quality of service settings, as well as a callback function to be run every time we receive information over the designated topic. Now, in this subscriber callback, this will take in the message type we're receiving. And notice we use the ampersand symbol before the variable, which just means it's a reference parameter. That way we're not copying over the information. Then we can utilize this message object to get the information we're interested in. In this case, we were interested in the data attribute of our string message to see what string information our publisher sent over.